Alright, today I'm going to try to make this as painless as possible. We're going to be talking about reversing motors. Why do we need the capability of reversing motors? So a little backstory, all electric motors are used to convert electrical energy into a rotating mechanical force that performs work. We know that from Motor Controls 1. The amount of required work depends on the application, which also determines the motor size, the type, control requirements, etc. Some motor applications are going to require the motor to operate in only one direction, and other applications require the motor to be reversible. So when motors are used to operate loads, for example, pumps, escalators, and timers, the motor must operate in only one direction. If the motor is reversed, the loads and driven components could be damaged. When motors are used to operate loads such as overhead doors, elevators, cranes, electric boats, electric trains, etc., the motor must be designed to be reversible by an external control device or circuit. All motor types, except the shaded pole motor, are reversible and can be designed to be reversible by bringing the required motor internal wires outside of the motor. Three-phase and DC motors are reversible without bringing out additional internal motor wires. To be reversed, split-phase and capacitor-type motors must have their starting winding leads brought outside of the motor. So learning how each motor type is reversed and knowing the reversing component or circuit requirements is important when we're designing, installing, servicing, or troubleshooting any application that requires the motor to operate in both directions. So how can we reverse a motor using manual motor starters? A manual starter is a contactor with an added overload protected device. Two manual starters are connected together to create a manual reversing starter. Manual motor starters are used in pairs to change the direction of rotation. Motors cannot run in forward and reverse at the same time. That's pretty obvious. And if they tried to do it, it would severely damage the equipment. So we have to include some preventative measure to keep both starters from energizing at the same time. And that's going to be mechanical interlock. This prevents both sets of contacts from being closed simultaneously. This is going to be the last preventative measure that would be taken. So it's all or nothing when it gets to this point. The first preventative measure you would want is to be an electrical interlock. That's what you're going to rely on the entire time. So this is just a picture of what the contactors look like when they are connected. You can see your left contactor, your right contactor, and then that mechanical interlock in between them. And they're both going to be connected together while you do this lab. So how do we reverse a motor normally? So normal operation, we know that we're just going to run line 1 to T1, line 2 to T2, and line 3 to T3. But when we're reversing a motor, let me put that over there so maybe you can see it a little bit better. Line 1 and line 3 are just flip-flopped. So line 1 is going to go to T3, line 3 is going to go to T1, and you leave line 2 alone. You could reverse line 1 and line 2, but normally across the industry standard is going to be just flip-flopping 1 and 3, so that way you can leave L2 to be a constant. Alright, so here's a diagram, and this is what you're going to be working on in your lab. And as you can see, you got your stop push button. So just like how we did the seal-in circuit. So the stop push button, we're going to go through it first. Then we're going to come out of it and go through one side of the forward and one side of the reverse. So it's just going to do a loop-de-loop-de-loop. Alright. And then we're also going to have one side of our forward push button and one side of our reverse push button connected to a normally open contact. Then on the other side, we're going to have that connected to a normally open contact and also the normally closed contact of the opposite contactor. I know that's a lot to take in, so don't panic. So first, we're looking at our contactors. You got your three-phase voltage ran just like usual. So you got line 1 to T1, line 2 to T2, line 3 to T3. And you've got your control voltage. So anytime we're dealing with anything control side, it's going to be 24 volts to 0 volts. Your 0 volts is just your neutral. So if you see a schematic and it says neutral, that's going to be your 0 volts. So looking at this, over here where you see stop, forward, and reverse, I'm just calling those your push buttons. So we've already discussed that why we should run our power through our stop button first. And why is that? That's because when we press that, we want it to stop everything. So it is the first thing that you run that 24 volts to. So you run it through your stop and you come out of your stop. So in one side, out the other. You come out of your stop and go to one side of the forward and then jumper that side of the forward to the other side of the reverse. So you can see, if you follow that yellow line up there, out of the stop, forward, reverse. So keep the forward and reverse on the same side for that step. Then, you can't see that part. Okay, so then on coming out of your reverse, so we'll just call you come out of your outlet on your stop and go into your inlet of your forward and reverse. We'll say that. Then come out of your outlet on your reverse, go to your normally closed contact, then out of your normally closed contact to your A1. Alright, on the opposite contactor. So whichever contactor you're calling 1 and 2, that's the one you go through first. So you would go through from your reverse button through your forward contact. So in this drawing that I've done, our forward contactor is on the right. And I hope that makes sense. Because we're coming out of the reverse, going through the forward, and then to the reverse contact. And if you can tell, I've also got my neutral or my 0 volts going to my A2s. So we've tied that up already. Alright. Now looking at this, now I've ran from my outlet on my forward to the normally closed on the reverse contact and then back to my forward. So it's literally just like flip-flop. So out of our reverse, we go to the forward contactor, normally closed, out of our normally closed to the A1 of our reverse. Out of the forward, we go to the reverse contactor and then back to the forward. Alright. And now this is where it kind of looks like just a jumbled up mess and it's going to get kind of confusing. But you can see up top that I have the reverse contactor on the left and the forward contactor on the right. And just looking back at the line diagram, the schematic, we can see that out of one side of the forward, we have it going to a normally open contact, which is 13. On the other side, we have it going to 14-22, which is our other normally open contact. On the forward contactor, now we're doing the reverse. So we need it to be normally open. So it's going to go to 13. And then out of the other side, it's going to go to 14-22 because 13 and 14-22 are our normally open contacts. We don't use the normally open contacts down there by the normally closed contacts. I know that's confusing. But we would only use those normally open contacts if we were going to implement, say, a buzzer or an indicator light to show that they're open. So, I know I've probably confused you, but once you get your hands on it, it makes a lot more sense. So basically, the gist of this is, if we press that forward button, that forward push button, it is going to make it to where the reverse cannot be closed in. So you can see we go through our stop push button and say we press our forward push button. It's going to close that normally open circuit in, and it's going to open that normally closed reverse. And vice versa. If we did the reverse button, it's going to open that normally closed forward contact right there at the bottom, and it's not going to allow the opposite to happen. So if you push that forward, it cannot go in reverse, period. There's your electrical interlock. If you push that reverse, it's not going to allow it to go to forward. So, let's see, where's my pen? the way I look at it to make it not quite so confusing, even though it is confusing, and I know it is, because it still confuses me sometimes. So it's okay to be a little lost. So you can clearly see that we got our 24 volts going straight through our stop push button. And now we connect our 24 volts to one side of the forward push button and also to the reverse push button. So remember when I said we're just jumpering, so completely go through the stop in the inlet, out the outlet, but just go in the inlet of the forward and the reverse push button. So that takes care of that. Now, also on this side, the inlet side, we're going to go to one of our normally open contacts on our forward contactor. On the other side of our push button, we're going to go to the other normally open contacts, so our 13 and 14. And then we're going to go through the normally closed of the reverse. You see how that's kind of making sense? And then vice versa. So now we have to go on the same side, our inlet. I just call it the inlet because it makes it a little bit simpler. We're going to go to one of our normally open contacts, 13. And then on our outlet, we're going to go to one of our normally open contacts on our reverse contactor. And that's 14-22. And then on that same side, right here, we're going to go to the normally closed contacts on the forward contactor. So that's when we use the NCs. So that would be 95 and 96 if I do recall. So you're going to go in one and out the other to the A1 of the other contactor. And I know this can be a little confusing and everything, but if you have any questions, we're here to help you. But just look back at this, and if you need to like redraw and trace out your steps and even put the numbers that you know you're going to go to. So if you need to put, like for your normally open, say 13 and 14, 13 and 14. So those are your, and that's going to be 14-22, just so I don't get it confused. And then on your normally closed of the reverse, so you would use a normally closed, and then you're going to go to the A1. Normally closed, go to the A1. And then let's say, since we're going to be using the normally closed on this side, so it'd be 95 and 96. 95, 96. All right. Go back into that. And see on our one side, so we're just going to go ahead and trace out the 24 volts. So we got 24 volts going to the inlet, all the way through the stop, to the inlet of the forward, and to the inlet of the reverse. And then you can kind of see from there what you're going to be doing. So if you have any questions, don't panic. Just let us know. But at the end of this, it should look something like this. So over here is your push buttons, obviously. And this is what your contactors should resemble. So 13 and 14 are going to have wires in them, A1 and A2. Your normally closed over here, and they're 95 and 96. They're going to have wires in them, and then obviously your three-phase. So you are not going to use those normally open contacts at all. All right, and just let us know if you have any questions, and we'll be here to help.